Hello, I'm Bill Wong with Electronic Design, and today we're going to talk to NXP about solid-state radar. So where are we stand right now with respect to solid-state radar?
Yes, good question, Bill. So solid-state radar has come a long way, right? From the times of big bulky boxes that would detect a blip on a radar screen, we've now come to the newest generation that is really highly integrated, allows us to fit into a small form factor as small as 5 by 5 centimeters, based on our most recent generation single chip, and providing us enhanced capabilities, radar-based perception, if you will, where now we are able to detect not only distance, speed, angle of arrival of the object, we're as well able to detect the vertical dimension, thereby do radar-based object classification, and a major step forward overall.
Excellent. So could you tell us about the latest chip you've just announced?
So what we are looking at right now is our new single chip integrated radar transceiver built into a form factor radar sensor shown at the upper part of this display. Very compact configuration, a 5 by 5 centimeter sensor form factor that allows mounting into occluded places, mounting behind the bumper, which is very important in nowadays OEM implementations. The sensor as it is provides the full capability of our third generation 28 nanometer RFCMOS long range detection, 200 to 300 meters worth of detection range, and provides as well elevation sensing the vertical domain on top of speed, distance, as well as angle of arrival. This is actually the inside of the sensor.
Okay.
So this is the PCB that is in the sensor. So you have the chip itself here, and you have the antenna side that is inside that sensor module over here. It's the industry's first 28 nanometer RFCMOS single chip, which is important for a couple of reasons. So first of all, the single chip integration enables a much smaller form factor, so 30% smaller than previous generations. And secondly, our third generation RFCMOS, now in 28 nanometer, as compared to 40 or 45 nanometer used by other radar chip providers, improves performance substantially. And what does that mean? So on the one hand, we get better link budget. So we can see further down the road, 300 meters and more detection range. We can detect smaller objects, and we can separate objects spaced closely more accurately. Means we are able to now separate vulnerable road users, pedestrians next to a parked car, or bicycle riders or motorcycle riders next to a truck in the street, which is very important to enhance road safety.
Okay. So do you have development kits available, or are there other applications where you're targeting this?
Yes, indeed. So what we have available are actually a couple of things. So we have classically our component evaluation boards that help customers get jump started, and we provide that together with our radar development kit, with our radar software development kit, which nowadays as well includes enhanced radar algorithms that are used for high resolution processing, interference mitigation, and MIMO waveform support. More so, we have worked with a partner of ours to develop a form factor sensor that is available for customers that want to make use of a ready-made off-the-shelf sensor in order to integrate it into their end system, which is often used for adjacent market applications like traffic monitoring, like mining applications, like logistics applications.
Excellent. Well, thanks for filling us in on NXP's latest solid-state radar technology.
Much appreciated. Thanks, Bill.